Welcome to the system reset of the HT8 MCU basic tutorial. This chapter will take you to understand the system reset function of the HT8 MCU from two aspects, which are reset function introduction and reset method introduction. Reset function introduction. What is a reset? For example, this is an indoor thermometer. The thermometer starts to measure normally and shows that the temperature is now 26.3 degrees. At this time, the thermometer is subject to some external interference, such as radiation, static interference, etc., resulting in the MCU cannot operate properly, and the screen displays garbled codes. If an exception is detected, the system is reset. The thermometer restores to its initial status after a short reset period. Then continue to operate normally. So back to our question, what is a reset? After a short reset time, the function of restoring the MCU to the initial status or preset status is known as a reset. When a reset is required, there are several common situations. Power on reset. After power is first applied to the MCU, it will be automatically reset. External interference. The MCU needs to be reset when it cannot operate properly due to the external interference, such as electromagnetic, power, static, and other interference. Low voltage. When the operating voltage is too low to affect the MCU normal operation, the MCU needs to be reset. Active reset. The reset can be triggered at a specific time according to user solution requirements. Next, let's introduce common reset methods. The reset methods include hardware reset and software reset. In this series of MCUs, the common hardware reset methods are power on reset, reset pin reset, low voltage reset, and the watchdog timer timeout reset. In different operating modes, the watchdog timer timeout reset has different initialization status. The common software reset methods are RSTC register software reset, LVRC register software reset, WDTC register software reset. The required reset time varies with the reset method. For details, refer to the corresponding datasheet. The different reset methods will also have different reset initial status. Generally, the initial status after a reset is that the program counter will be reset to 0. The time bases will be cleared. The watchdog timer will be cleared and begin counting. And the stack pointer will point to the top of the stack. In addition, the different reset methods correspond to different flags. Let's first understand two registers, namely the status register, which is a status register used to record the status and operation of the microcontroller system, and the RSTFC register, which is associated with some hardware and software reset flags. The hardware reset flags are related to the TO and PDF bits in the status register, and the LVRF bit in the RSTFC register. The TO bit is the watchdog timeout flag. The PDF bit is the power down flag. When the CPU stops running, the PDF bit is changed to 1. The LVRF bit is the low voltage reset flag. The software reset flags are related to the RSTF, LRF, and WRF bits in the RSTFC register. The RSTC register software reset flag is known as RSTF bit. The LVRC register software reset flag is known as LRF bit. The WDTC register software reset flag is known as WRF bit. When a reset occurs, the relevant flags will be changed, which will be explained later. Reset method introduction. The first reset method is the power on reset, which is a reset generated when power is first applied to the MCU. After reset, the registers will be restored to their original status. All I/O ports will be kept high to ensure that all pins are set as inputs after power on. The watchdog timeout flag TO and power down flag PDF will be reset to 0. Taking the HT66F3195 as an example. A reset occurs after the MCU is powered on. it begins to operate normally after about 16 milliseconds, during which time a series of reset actions are performed inside the MCU. The reset pin reset is a reset generated when a low pulse signal of at least 10 microseconds is supplied on the reset pin. After reset, most registers will be restored to their initial status, and a few registers will remain unchanged. At the same time, the watchdog timeout flag TO and power down flag PDF will remain unchanged. As shown in the figure, when a low level is supplied on the reset pin for at least 10 microseconds, the MCU will be reset. When the reset pin rises to a certain voltage, the MCU will restore to normal operation after at least 16 milliseconds. Therefore, when the MCU reset requires to be controlled by an external signal, the reset pin reset can be used. For applications that operate within an environment where more noise is present, the enhanced reset circuit is recommended. That is, a resistor is connected between the VDD and reset pins, and a capacitor is connected between the VSS and reset pins to form an RC circuit, which will ensure that the reset pin remains low for an extended period to allow the power supply to stabilize, resulting in an MCU reset. The components marked with an asterisk can also be added depending on requirements. Note that any wiring connected to the reset pin should be kept as short as possible to minimize any stray noise interference. In addition, the RSTC register should be set to 10101010 to enable the reset pin reset function. When the RSTC register is set to other values, or when the value of these bits is changed due to the external interference, the MCU will be reset, that is, the RSTC register software reset. At the same time, the RSTC register software reset flag RSTF will be set to 1. The low voltage reset, which is used to monitor the supply voltage, occurs when the operating voltage falls below the set value and keeps for 240 microseconds. After reset, most registers will be restored to their initial status, and a few registers will remain unchanged. The low voltage reset flag LVRF will be set to 1. As shown in the figure, when the power supply voltage is below the set value and continues 240 microseconds, the MCU will be reset. When the power supply rises again and after at least 16 milliseconds, the MCU will restore to normal operation. The low voltage reset voltage setting value is set by the LVRC register. So, when the power supply voltage is reduced to a certain value due to instability or power consumption, which may affect the normal operation of the MCU, the LVR reset can be used and set according to this value. In addition, when the LVRC register is set to other values, or when the value of these bits is changed due to the external interference, the MCU will be reset, that is, the LVRC register software reset. At the same time, the LVRC register software reset flag LRF will be set to 1. Finally, the watchdog timer overflows, causing the system to reset. This reset prevents a crash or external interference from causing the MCU to function improperly. In different operating modes, the initialization status of the watchdog timeout reset is different. In normal operation modes, after reset, most registers will be restored to their initial status, a few registers will remain unchanged, and the watchdog timeout flag will be set to 1, and the power down flag PDF bit will remain unchanged. As shown in the figure, after the watchdog timer overflows and generates a reset, the MCU takes approximately 16 milliseconds to restore to normal operation. In the idle or sleep mode, after reset, the program counter and stack will be cleared, most registers will remain unchanged, and the watchdog timeout flag TO and power down flag PDF will be set to 1. As shown in the figure, after the watchdog timer overflows and generates a reset, the reset time required by the MCU varies according to the clock source and the system clock on or off status. For details, refer to the corresponding datasheet. For example, when the system clock is switched off and the system clock is provided by an external low-speed oscillator after wake-up, the reset time is 1024 external low-speed oscillator clock cycles. In addition, the WE4 to WE0 bits of the WDTC register should be set to 01010 to enable the watchdog timer. When the WDTC register is set to other values, or when the value of these bits is changed due to the external interference, the MCU will be reset, that is the WDTC register software reset. At the same time, the WDTC register software reset flag WRF will be set to 1. The watchdog timer will be explained in detail in the subsequent course. Course summary. In this course, we have learned about various MCU reset methods. Through the study of this course, you will have a clearer understanding of the system reset. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.